Hello, my dear students of first secondary. Today, inshallah, we are going to study a new lesson, which similarity part 3. Sorry, we are going to find out the relation between similarity and areas. So concentrate with me, please. We here a triangle like that. And another triangle like that. This triangle called A, B, C, and this one called X, Y, Z. And this first triangle, it's supposed to be similar to second triangle. So we write here triangle A, B, C is similar to triangle X, Y, Z. And we want to find out the relation between the ratio of the area of the first triangle A, B, C over area of second triangle, which is X, Y, Z. Now we have to prove that. What is the area, what is the ratio between the area of triangle ABC and the other triangle AXYZ? And they are similar. Okay? We are going to draw a perpendicular from A to BC here. Say E. And another perpendicular from X to D. So we have AE perpendicular to CB and XD perpendicular to ZY. If you want to find the ratio between the area of triangle ABC to the ratio of triangle XYZ, we will write the area of triangle ABC equals half, as you know, times base, which is CB, times height, which is AE. And the area of triangle XYZ will be half ZY, which is base, multiplied by the height, which is XD. So we can simplify this. Half cancelled with half, so the final answer will be CB multiplied by AE and ZY multiplied by XD. Okay, and we know that the two triangles are similar here, so we can write their ratios here. AB over XY equals BC over YZ equals AC over XZ. Okay, try to compare this part and this one. We will find out that here we have BC or CB over ZY. Okay, and we will try to prove that the triangle ABE here similar to triangle XYD. We have here, from the similarity of the first two triangles, we will find out that measure angle B equal measure angle Y. And we have already measure angle AEB equals measure angle ADY. So the two triangles are similar. And we can write them as the following. Triangle ABE is similar to triangle x, y, d. And we can write AB over xy equals BE over YD equals AE over XD. We have here, if we compare between the two triangles here, this triangle and this one, the two ratios, we will find out that AB over XY exists here and AB over XY exists here also. So these ratios are equal. So we can replace any of these two ratios by any one here, because all ratios here equals all ratios here. So we can replace AE over XD by CB over YZ. So we can write area of triangle ABC over area of triangle XYZ equals AE over XD multiplied by CB over ZY. And we can replace this by CB over ZY multiplied by CB over ZY, which equal, to be clear, which equals CB over ZY all power 2. So we can deduce now that the ratio between the area of triangle ABC to the ratio of triangle XYZ equals any ratio or any scale factor but power 2 or squared. We can, okay, my dear students, we can conclude this ratio by the following. Look here with me. If we have two triangles like that, A, B, C, and another triangle X, Y, Z, so the area between triangle A, B, C over area of triangle X, Y, Z will be equal in ratio, which is sometimes to be AB over XY, but all power 2. And we know from the previous that perimeter of triangle ABC over perimeter of triangle XYZ equal the same ratio but not power 2. Area only, the ratio between the two areas of the triangle only will be AB over XY squared. But perimeter of triangle ABC over perimeter of triangle XYZ will be the same ratio, which is the scale factor. Now concentrate. The ratio between the two areas equal any ratio but power 2. Perimeter equal just the ratio. And concentrate with me to find an example, my dear students. We will solve examples to be clear to you. So concentrate with me. Now we have a triangle here like that, A, B, C, X, Y here, and we have parallel. What is parallel what? X, Y here, parallel to CB. And we have the ratio AX over XB equals 2 over 3. So write here the ratio of our AX equal 2 and the ratio of XB equals 3, to be don't forget that. And given that area of the triangle ABC equals 62.5 square centimeter. We have the area of the whole triangle ABC here equals 62.5 square centimeter. And we have the ratio AX to XB equal to over 3. And the request or the required to prove is to find area of the quad XBCY. Okay, we would like to find the area of this quad only. So we know that triangle AXY and triangle ABC are similar. Why they are similar? Because we have here XY parallel to BC. So we will deduce that this angle, which is AXY, equals the measure of this angle, which is ABC. And we have this angle also equal this angle corresponding. And we have the third angle is common between the triangle AXY and triangle ABC. So that easily to prove that triangle AXY similar to triangle ABC. And we will deduce that area of triangle AXY 2 or over area of triangle ABC equals what? Any ratio of these triangles but power 2. So we can choose the ratio AX over AB. AX over AB power 2. And we have that the ratio between AX and AB, here the ratio of AB equals 5. So we write 5 here. And do not forget, my dear students, that all of them are power 2. So it's 4 over 25. And we have the area of the big triangle, which is 62.5. By substitution, we will find that area of triangle AXY over 62.5 will be equal 4, this is the ratio, 4 over 25. So we can find out easily area of triangle AXY equal 4 multiplied by 62.5 over 25, which will be 10 centimeter. So area of triangle AXY equal be 10 square centimeter, because it's square unit, it's area. But we want to find the area of quad XBCY. And we know that the area of the quad XBCY equals the area of triangle ABC minus the area of this triangle, which is now is 10. So area of quad XBCY equals 62.5 minus 10, because we have the area of a whole triangle here 62.5, and the area of small triangle AXY equals 10 with proof here. So the area of the quad XBCY will be easy now to find it as 52.5 squared centimeter. So now similarity thanks to it, or thanks to similarity, it's easy to find out the area of any of these two triangles or quad. My dear students, similarity is very easy. It is a whole unit in your book, 5 lessons, and we hope inshallah today to close it and finish it. So concentrate with me again. Here we have a circle here, and we have here AB at the chord, or AC, sorry, and we have AB here, and we have a straight line D, and we have AD, and we have here AB equal 5 centimeter, it is given now, and AC equals 3 centimeter. Okay, the request is the ratio between area of triangle ACB here, ACB, and area of triangle ABC. He would like to find out the ratio between this triangle ADC and the area of this triangle ABC. We will try to find similarity. Similarity is our solution and our savior now. We have the small triangle ACD here and the whole triangle ABD. We try to find a relation of similarity between them. So we know that the measure of this angle equals the measure of this angle. Why? Because this AD is a tangent here, so the interior angle equal angle here of tangency, and we have D. It's very important angle for us. D is a common angle. Common angle between what? Between triangle ADC and triangle ADB. So it's a common angle equal in each of two triangles. And we have another angle which is DAC equal measure angle B, because this is a tangent and this is angle of tangency, and this one is an inscribed angle in the opposite side. So we can easily deduce that triangle. We try to write it correspondingly. We start with this dot A, and we will start the other triangle with this dot also, which is B, and this is area of triangle A what? ADC. Why D? Because it's common angle. And this triangle will be BDA. The order is very important for us. Okay. If you want to find out any ratio between them, we will find that the area here equal the ratio. First ratio is AD over BD. But don't forget it's power 2. And we have another ratio, DC over DA. Don't forget it's power 2. And the final ratio, AC over BD. And don't forget also it's power 2. Do we have any ratio here? We have also AC and AB. Where is AC? This is AC and AB. Okay, we'll concentrate again. It will be DA over AB, it's A here, and AC over BA here, it's DC over DA here. So we have 3 over 5, and we write power 2 here, and the answer will be 9 over 25. This is the ratio between what? The ratio between area of triangle ADC and area of triangle ADB equals 9 over 25. But we want the ratio between the small triangle here, which is ADC, and the small triangle here also ACB. But we have in the denominator here all triangle. The solution will be area of triangle ADC over area of triangle ADB minus the area of this triangle, which is area of triangle ADC. But is it acceptable to make minus here? Yes. If we put here 9 equals 25 and we subtract the 9 here, as we subtract the numerator, it's the properties of ratio, it will be 9 over 16. So my dear students, if subtract here the denominator from the numerator, or here this one from 1, we have make this also in the another side. So area of triangle ADC here over area of triangle ADB minus the triangle ADC will be equal 9 over 25 minus 9 will be 9 over 16. Okay. We have also another question. Concentrate with me, my dear students, and we'll find. Okay. Let us to go to short break for 3 minutes only, and we will return again. Thank you.
وانت ماشي في مصر سلم عاللي ربى وعاللي علم واللي كبر واللي عقل واللي هاوي واللي فهم. وانت ماشي في مصر سلم عاللي ربى وعاللي علم واللي كبر واللي عقل واللي هاوي واللي فهم عالتاريخ اللي بيكتب اسمها في كتابه حاضر عاللي بتربي ابنها من صغره يكبر يبقى راجل عالتاريخ اللي بيكتب اسمها في كتابه حاضر عاللي بتربي ابنها من صغره يكبر يبقى راجل عالبنا والبنايين والخضار والفلاحين والايدين الشقيانين لف بعيونك وشاور انزل امشي في الشوارع زور كنيسة ودير وجامع اللي شاف غير اللي سامع مصر سحر مالوش آخر عالبنا والبنايين والخضار والفلاحين والايدين لف بعيونك وشاور انزل امشي في الشوارع زور كنيسة ودير وجامع اللي شاف غير اللي سامع مصر سحر مالوش آخر.
Hello again, my beloved students. We are going now to study the applications on similarity and circle. So concentrate with me. We have here a circle like that. Okay, and we have two chords intersect inside the circle, like these two chords. We have a chord here and another one here. We know that the chords, any two line segments meets 2 points on the circle. It is not necessary to pass through the center of circle. So we have the first one equals EB here and XY, and we have here the intersection point, which is E. We have a very important relation between the parts of these chords. If we have the length of AE and EB, and also we have the length of AE and EY, we will find out the XE multiplied by EY will be equal AE multiplied by EB. If we have this one equal 3 centimeter and this one equal 6 centimeter, and we have EB equal, okay, we can change. We have 4 and 6. EB will be 12 centimeter and this is 2 centimeter. If you multiply 4 times 6 here and multiply 12 times 2, they will be equal because all of them equals 24. Why this relation can be? Why this part times this part equals this part times this part? It's from similarity. And if we have joined this part and we will join this part also, we will find out easily that measure angle A here equal measure angle X and measure angle B equal measure angle Y. So these two triangles are similar, and we can write them as the following. X E B, this triangle will be similar to AEY, and it's easily to find out that XE over AE will be equal XB over EY equals XB over AY. And we will try to find the relation between XE, this one, and AE, this one, and EB, not XY, EB over EY, EB here, sorry, EB over EY. And we will find out that XE multiplied EY equal AE multiplied EB. So this part multiplied by this part equals this part multiply this part. That's from similarity. And we will discuss another part. We have, my dear students, two chords but intersect outside the circle. Now, the previous one, two chords intersect inside the circle. So we will draw a circle here. And we will draw also two chords but intersect outside the circle. We can call them, that's E, A, B, and CD. And we have two parts here, which is AE and AB. And we have another two parts here, ED and DC. And we know that if we multiply AE times EB, concentrate with me, EA multiplied by EB will be equal to the other part, which is ED multiplied by EC. ED times EC. Why this has happened? We will find out why this part multiply this part equals the small part multiply this part. Also from similarity, if we join AD and BC here and try to prove that this small triangle, which is AED, similar to the triangle BEC, we will find out, or we will deduce this relation. Now we have this angle is a common angle between the two triangles. It's an angle here for the triangle EAD, and it is the same angle for the triangle BEC. So it's common triangle. And we know that this is a circle, and this angle equals this angle also. Why? Because this part is a cyclic quad. From previous studying for you, we have here circle passes through B, C, D, and A. So A, B, C, D is a cyclic quad. So the exterior angle here equals the measure of interior angle here opposite to its vertex. So we can say that this is a common angle. This angle equals this angle. So we have AA similarity, or angle-angle similarity. So we can easily prove that triangle AED similar triangle to triangle ECB. We can write them in order, as we say. Triangle AED is similar to the big triangle, which is E, here A, then we start with the C. C what? CE. B. We have the triangle AED. We start with this triangle, then the common, and the big triangle we will start with the equal angle to A, which is C, CE, which is the common angle B. So we have here AE as a ratio over CE equals ED over EB equals AD over CB. We try to find out the relation between these parts. Where is AE here? It's here. and CE is there. Where is ED? Yes, it's this one. So this one. So concentrate with the two ratios. We will find out easily that AE multiplied by EB equals ED multiplied by CE. Try to connect these with each other. We have here AE, which is the first part, multiplied EB will be equal ED multiplied EC. So easily, my dear students, we proved that these parts are really proportional, and we now are going to try to solve many or some questions on it. Okay, concentrate with me now. We have a circle here. It's a circle, and we have two chords intersect in the side of the circle like that, and this one also. This one called DC and this one called AB, and we have intersection point which is H, and we have length of HA equals 3 centimeter and the length of HB 2 centimeters, and we have CD as a given. CD, all of this part equals 5.5 centimeter, and we would like to find out the length of HD and the length of HC or HD and CH. We would like to find the length of the two sides. What we do now, we have also the DC totally. We can suppose that DH equal X. So the length of HC, yes, I am hearing you, 5.5 minus X. It's easy for you, my beloved students. If we suppose one of them equal X, the other one will be 5.5 minus X, because the total length here equal 5.5. And we will try to applicate the relation between them. We have here DH multiplied by HC will be equal BH multiplied by HA. Okay, put the numbers. DH equals X multiplied by HC, which is 5.5 minus X, equals BH, which is 2, multiplied by HA, which is 3. And this lengths are not scale, so concentrate only for the numbers. We have here 2 times 3 equals 6. X multiply 5.5 will be 5.5x minus x times x equal x power 2. Now we have here algebraic form of the quadratic equation. So try to put it in the form. Here we can put negative x power 2 plus 5.5x minus 6. When we transfer this, 6 will be negative equal 0. And multiply all of them by negative, because it is not acceptable for x power 2 to be negative. So it will be x power 2 minus 5.5x plus 6 equals 0. And try to solve it using formula, or you can use factorization. I will use factorization here, 2x minus 3 here. We will multiply by 2 here, it's easy for you to be 2x power 2, and we try to overcome this point. If you multiply it by 2, it will be 11. It will be easy. And 6 will be 12. So it will be easy for you to factorize it. So 2x power 2 factorized as 2x and x here. We have here plus 2, it's negative times negative. And we have here 12. It will be 3 times 4. So 2x minus 3 will be 0. So x will be 3 over 2. And x minus 4 will be 0 also. So x will be equals 4. What is x here? 1.5. And what's here is 4. So one of them, which is smaller, which is dh, will be equal 3 over 2 or 1.5, and the other will be the 4. Okay? Now, my dear students, we already find out the solution, and we have many questions here to solve. We have here a circle. Concentrate with me. Forgive me about the circle. We have here two chords but intersect outside the circle. It is H now, D and C, here B and A. And we'll put the length of the sides. We have BA here equals 7 centimeter and BH equals 2 centimeter, and the ratio between HD and HC equals half. So HD equal what? Is it equal 1? No, it's wrong. It's really equal 1 multiply a number, and HC number 2 multiply the same number. We can put this number as x or y or any symbol. So HD will be 1x and HC will be 2x. And now we will try this 2x is all HC. Concentrate with me. This x only for HD. So we will applicate the relation between them. We have HD here multiplied by HB, HD times HA equals what? Equals x multiplied by the whole number HC, which is 2x. So we can multiply x by 2x here, will be 2x power 2 equal HD, which is 2 centimeter, multiply HA, which is 9. Yes, 9, not 7, because it's a common fault for some pupils that get 2 and after that he say 7. No, HB equals 2 and HA equals the sum of these two sides, so it's 9. We can cancel 2 with 2. We have x power 2 here equals 9. By taking the square root of the two parts, we will find that x equal positive or negative 3. But we know that we deal with length, and length we have no negative, so it's refused. And we have x here equals just 3. So HD HD here, which is x equals 3 centimeter, and dx also equals 3 centimeter. Why? Because if HC equal to x and this part HD equal x, so theoretically all of them will be equal. So HD equal x, which is 3 centimeter, yes, and DC equals 3 centimeter. Okay. We have also another question for you. Yes, try to be concentrate, my dear students. If we have a circle and the two chords intersect inside the circle, so we can multiply parts are equal, and if we have two chords intersect outside the circle, we have another parts of solution. So let's concentrate with me. We have here a circle. I try to solve it well, and to be clear, put my pen here, tracing. We have here a circle, an acceptable one, and if we have tangent for this circle, we have A is a tangent, touch the circle at the point A, and we have a secant here. This will be secant because it cut the circle, and we can call this point D, and this point is C. We have something, we called it corollary, just R, corollary. Okay, what is the corollary here? It's something like a theorem. We can solve questions with it. EA power 2 equals ED multiplied by EC. ED times EC. So concentrate with me well. If we have a tangent to a circle, we can find out EA or any part of them by this relation. EA power 2 equals ED power 2 equal ED also, just ED multiplied by EC. This is the relation. Okay, and we have a question on it here. Let's concentrate here. Let's try to draw another circle for you and trace it to be a good circle. And we have here a tangent, which is CM. CM is a tangent, and we have MA is a secant, cut the circle at 2 points, one of them A and the other point is B, and it's given that MC equal 10 centimeter, and it's given that MB X, and this part equals 15. So if this part equals 15, then MA equals what here? Exactly X plus 15. Okay, so applicate this relation between them. We have MC power 2 equals what? Equals MB multiplied by MA. MC power 2 will be 10 power 2 here, and MB will be X multiplied by MA, which will be x plus 15. We will try to expand x multiply x and x multiplied 15. So it's x power 2 plus 15x, and this number will be 100. Try to write it as a form: x power 2 plus 15x minus 100 equals 0. I take 100 here to be negative, and will be nothing here, so it will be 0, like that. And to be in the form, x power 2 plus 15x minus 100 equals 0. And by factorizing or by using the formula, we can find out that x minus 5 here, x power 2 is x and x, 100 is 5 multiplied by 20, and negative will be divided negative plus positive. All of them equal 0, so we can write x minus 5 here equals 0 and x plus 20 equals 0. We transfer negative 5 here, so x equals 5, and here x equals negative 20. Yes, excellent pupils say that this number is refused because we deal with length. When we deal with length, there is no negative here. When x equals 5, so MB equals 5. Okay, we have here, my dear students, every theorem has a converse of it, and this is well-known problem, and its converse we will study it now. So concentrate with me, please. We will try to finish similarity today. We have a circle here, and we have just, I will not trace now, I have two parts like that, and one part like that. We have A, B, C, D, and E. If we have something like that, and he asked me to prove that B, C, D, and E lie on the same circle, we try to prove that B, C, D, and E are on the same circle. We will suppose a circle, but if we have proved that AB multiplied by AC equals AE multiplied by AD, that means that F AB times AC can be equal that AE times AD, then we will prove easily that the points C, B, E, and D are on the same circle. So the circle will be, we will dash it, not trace it completely. We try to prove it. This is if the two chords intersect outside the circle, and if we have another one and the two chords intersect inside the circle, okay, we have here two chords. These two chords intersect inside the circle. We can call A, B, C, D, and E, and we have CE multiply ED, this part, times this part equals AE times AB, which is this part multiply this part. If we find out that this part times this part equals this part times this part, then it will be A, B, D, and C are on the same straight line. Okay, thank you for joining us, my dear students, and we will meet again inshallah the next Friday. Goodbye.